Okay, good evening all of you. And today I'm going to tell you polar form of conic. As directly polar form is not in JEE syllabus, but soon you will see how I'm going to apply this a very beautiful and simple concept to solve JEE questions in a very quick manner, especially seeing the recent trend of JEE when you have very less time, especially for maths to solve the problems because of the length of the paper. So here we go. So what's polar form of conics? As you have seen, the definition of conic section goes like this. It's a locus of point P in R2, which is 2D, such that distance from a fixed point and a fixed line is constant. And that constant, depending upon its value, it will produce a straight line, pair of straight lines, circles, parabola, hyperbola, or ellipse. So since polar form, I'm assuming like it's already known to you. So given a point x comma y in coordinate plane, it can be given a point x comma y in the coordinate plane, its GPS location can be also stated in terms of r and theta, which is x can be written as r cos theta and y is r sin theta. Sp by pm equals c to derive the polar equation of conic section. So let's say I set up origin at the focus itself, that is the most convenience point. So s is 0, 0, because I can always translate the axis and make focus to be origin. So given any point P on this conic, it can be any part. Don't get confused by the diagram because it can be even ellipse or circle or hyperbola. For the sake of drawing, I have just taken some random conic. So if I take a random point P here, Sp by Pm is equals C. So let's say the point P is such that its GPS location is r and theta. So theta is the angle that is making with the axis of conic. Axis means a line which is perpendicular to passing through focus and perpendicular to directrix. So its orientation is theta. So let's say the GPS location of point P with respect to S is r and theta. So its distance is r from S and is making angle of theta with axis in anti-clockwise sense. Axis is this line which is passing through focus and perpendicular to directrix. Just we need to just plug the informations now. So Sp equals Cpm. What is Sp? It's r, and Pm, this distance is nothing but full distance minus Fd, where F is foot of perpendicular drawn from point P to the axis. Now it's quite easy to find SD because we know like there is a special term associated with any conic which is latus rectum. So latus rectum is a line, in fact chord, which is passing through focus and perpendicular. So length of semi-latus rectum is L. So what about this distance? It's nothing but L by E by definition of conic. So SD is L by E and SF is nothing but simply r cos theta. So if we'll plug this value, we are getting r equals L minus E r cos theta. Hence L by r equals 1 plus E cos theta. Now clearly to get the entire branch of this conic, we'll make one full revolution or one full rotation. To get the entire branch of the conic, we'll make a full rotation which forces theta to be defined either from 0 to 2 pi or from minus pi to pi. I've enclosed pi because it's up to you. You can enclose either minus pi or pi. Okay, so before we go further, let's see what does it represents, how the equation speaks on behalf of the known concept that we are having in xy plane. So for E equals 0, clearly it gives L equals R, which means a circle with focus as the center. For E equals 1, we are having 1 plus E cos theta. So E equals 1 will give L by R equals 1 plus cos theta. So R by L translates to 1 by 1 plus cos theta. So R by L translates to 1 by 1 plus cos theta. Now we know cos theta will dance from minus 1 to 1. So accordingly the denominator is dancing from 0 to 2. Now clearly 0 cannot be achieved, so let it make it open in a pure mathematical sense. So this quantity as a whole is going from half to infinity. I hope it is clear. Now this going to infinity has a significance because you see, according to our definition, focus was somewhere here and this is directrix line, and we define R to be the distance of any point from focus. Right, of course L is right semi-latus rectum, which is a fixed value, let's say 1, or you can put 3, 5, whatever. Okay, so anyway it will just scale up R, so R will increase. It does not impact the physics of maths. So now R will go from R by L, that ratio will go from half to infinity, or R will go from L by 2 to infinity. So just for qualitative feel, I'm putting L equals 1, and let's try to analyze how this curve will look. Okay, so r is basically distance and theta is this angle. So remember, as theta goes from as r goes from L by 2 to infinity, so what is L by 2? Okay, this quantity is the minimum value that you are getting. This is L by 2. Why? Because length of lattice rectum is L. Right, so this quantity will be L by E. Now E equal to 1. So exactly this is vertex. So these two distances will be equal. So L by 2 is nothing but SB, distance of focus from vertex, for some conic, whatever. Right now we don't know what is this conic, right? Okay, so now a simple analysis tells, like as r value is increasing, so as theta is increasing, like clearly the r value is increasing, it will go to infinity this way. Similarly, for two different theta, because of symmetricity, whether theta equals theta or theta equals minus theta, will get the same r value, and again it will go to infinity in this direction. So basically going in this direction, I am taking at positive infinity. Okay, so to get a feel with 3L by 2, so L by 2 is exactly this point. It's not the midpoint of S and this directrix point, like parabola, right? So this is the r value which starts from L by 2, it keeps on increasing and it will go to a point where this distance is becoming 3L by 2. Okay, but this is a focus. And again from 3L by 2 it will come back to L by 2. There is no way out. So here we are getting a closed curve. And clearly this represents ellipse with one of the focus, as I say. We can clearly reflect the entire system, okay, about the center of the ellipse to get another focus S dash and the directrix D dash. Next, let us appreciate what will happen for E more than 1. So as usual, we can again try. R by L is going to be 1 by 1 plus E cos theta. Now let's say E equals 2, just for feel. So 1 by 1 plus 2 cos theta. Even if we put any value of E more than 1, the qualitative aspect of the curve will not change. Just to give you a specific feel, I am taking a particular simple value, right? Now this quantity is again dancing from -1 to 1. Hence the overall dance will be 1 minus 2 to 1 plus 2. Right, so the denominator is dancing from -1 to 3. So clearly you can see 1 by this quantity will dance from minus infinity to -1. That's a crime too. Okay, so minus infinity to -1. So clearly you can see 1 by -1 to 3 will dance from minus infinity to -1 union 1 by 3 to infinity. And that's really crazy because you see r is becoming negative here. So one way you can just tell, like, since r cannot be negative, okay, so hence we can exclude this value, or other way, maybe the direction of r is changing, right? Because according to us, we are taking the direction of r as positive because from x and along theta, right? Okay, so let's see what does it mean. Again, we have got some focus, some directrix, and now this time, and let's say assuming L is L, it will move from minus infinity to minus L, L by 3 to here. So somewhere, so from L by 3, the point is starting and the radius is increasing till infinity, right? It will definitely increase in this way also. So this is the story when the point P, is on the left side of this directrix, right? What is the significance of minus infinity to minus L? Because if I am taking infinity in this direction, clearly minus infinity will be somewhere here, right? Because minus infinity means you are going in this direction. Okay, by the very convention and the very setup of mathematical formulation. So that shows you, like, this represents, we have minus L. So if I represent this quantity as L by 3, minus L means like somewhere on the other side of directrix we are going, right? Somewhere on the other side of directrix we are going. So we'll have some point there in the branch from minus L, and you keep on going to minus infinity. So this is naturally giving. So whether it's this branch or that branch, I can capture the feeling with respect to this equation. So I hope it is clear. Like basically, it makes sense that L equals R into 1 plus E cos theta is a very powerful equation, or L by R equals 1 plus E cos theta captures within itself all this diagram. Now let's see the beautiful application of this. Now obviously you can see when we are applying this formula, we need not worry about whether it's parabola equation, hyperbola, or here is a beautiful question which all of you know already, and let's try to solve it from parametric point. So we have a focal chord, let's say intersecting any general conic at point P and Q. So I'm not fixing its parabola, it can be any conic, okay, any conic. And this result is well known, 1 by SP plus 1 by SQ is 2 by L. It means SP is and semi-lattice rectum and SQ will be in harmonic progression. And you have proved this using simple XY plane technique, right? Let's try very smartly here. So this time again, if I take focus as S, and of course we'll have somewhere a directrix, which is of less to use here. So point P can be written as, let's say this distance is R. So what is the equation? I can write L by R equals 1 plus E cos theta, right? So let's suppose if this angle is theta, so this is clearly pi minus theta. Fine. So I can write, since R is nothing but SP, so L by SP equals 1 plus E cos theta. Now similarly we can write L by this length SQ, L by SQ. So that will also be following 1 plus E cos theta. So this time 1 plus E cos pi minus theta. Please note that you are not supposed to take R as positive or negative, right? Because that feeling is already taken care of by the angle. When I am defining angle to be from minus pi to pi, automatically, okay, I am giving a magnitude to radius R. And it's worthy to note here, like there is no need to take, like the algebraic sign of R here, over here, because that responsibility is given to the angle. Okay, so R is just increasing. Basically at these two angles, we have same R. So its length is 2 and 2. So R represents absolute value. It's not algebraic sign, absolute value. So this quantity goes to 1 minus E cos theta. And now you can clearly see L by SP plus L by SQ is going to be 2, independent of the location of P and Q, as long as you are passing through focus. So you take any chord, whether it's this one, or that one, or this one. So this proportion of lengths has a very significant and special property, that 1 by SP plus 1 by SQ equals 2 by L. And you see in one line we have proved this result. One of the beautiful application of this, and the question goes like this. Suppose you have an ellipse and we have got a focus S. Let's say we have two mutually perpendicular chord which is passing through focus. So PQ is perpendicular to AB. We have to prove that 1 by PQ plus 1 by AB is constant. Okay. In fact, this can be proved in more general for even parabola. Let's say we are repeating the same thing for parabola, AB and PQ, as long as the focal chords are mutually perpendicular, the result still holds true. It's true even for hyperbola. And the beauty for hyperbola is even we can select 2 points on the different branches. So PQ is still perpendicular to AB, right? And of course you can select on the same branch as well, right? So we can have diagram like maybe PQ and some AB. So both situations will give the same answer. So now my question is, for all these curves, this beautiful property will hold. Of course, if I would have asked you to solve this problem using XY, for different curves, your workings will be different. The equation of this line can be written as L by PS, so L by R, equals 1 plus E cos theta. What about L by SQ? Just now we have seen L by SQ is going to be 1 minus E cos theta. Similarly, with little bit angle changing, because this guy is 90, and that's not difficult because the angle that is making is pi by 2 plus theta, so 1 plus E cos pi by 2 plus theta. That's gonna give me 1 minus e sine theta. And 1 by SA is nothing but 1 plus e sine theta, because the angle will be pi minus this, right? So now we can clearly see what is length AB. So for length AB, we have SB plus SA, which gives L by 1 minus e sine theta plus 1 by 1 plus e sine theta. And that's evaluates to 2L by 1 minus e square sine square theta. In the same way, you can clearly see like PQ is SP plus SQ. That's giving you 2L by 1 minus e square cos square theta. And now we can find 1 by AB plus 1 by PQ. That will give 1 minus e square sine square theta plus 1 minus e square cos square theta by 2L. So we have nicely 2 minus e square, because sine square cos square theta will add by 2. And that gives you the final answer, which is 1 by L minus e square by 2L. So clearly eccentricity and length of lattice rectum is fixed. Hence this quantity is a fixed quantity for a given conic. And it's independent of the point AB and P and Q. Now you can see for the special case, if E is a circle, E will be equals 0. So 1 by AB plus 1 by PQ will be just 1 by L. And you can see what is length of lattice rectum in case of circle. Can you guess? It's a circle, and these two will just become a diameter, because focus has become the center of this. So you can clearly see like what is AB, 1 by 2R plus 1 by 2R, that's gonna be 1 by R. So lattice rectum for circle is R by this definition, right? If we'll put E equals 1, which is for parabola, so it's 1 by L minus 1 by 2L, and that's giving you 1 by 2. And this was, like this is a very beautiful result which holds even for hyperbolics. So there are many questions like this which can be very nicely tackled, especially those which involves distances. And one more I can just show you. So again we have a general conic with eccentricity E and length of lattice rectum, semi-lattice rectum as well. Let's say we have focus S, and we have got this time a focal chord PQ such that it subtends a right angle at focus. This is any general focal chord PQ. Of course, we can ask many questions like find the locus of midpoint of PQ, or find the foot of perpendicular from focus to the line PQ, or find the orthocenter of triangle SPQ, or centroid of triangle, or in center. So there can be so many, or circumcenter, basically that will be just midpoint of PQ. So many questions can be framed there. Now one of the beautiful question is you need to prove 1 by SP minus 1 by L whole square plus 1 by SQ minus 1 by L whole square is going to be E square by L square. Now you see, like clearly if you start writing the point on the conic, let's say if this question is posed for ellipse, involves distances, and when distances are involved, either you are using parametric form of a straight line to solve it, where you will generate quadratic and do something with the roots, or if you are going with XY method, it's going to be extremely lengthy because it will involve root over sum of squares of quantity x2 minus x1 square plus y2 minus y1 square. So here as usual, again we can beat this problem very nicely. So let's say this makes an angle alpha. So this quantity is 90, so our all angle is 90 plus alpha by Q. And hence question is done, because 1 by SP is 1 plus E cos alpha, 1 by SQ is 1 minus E sin alpha. So 1 by SP minus 1 by L is E cos alpha by L, and 1 by SQ minus 1 by L is E sin alpha by L. That will become minus E sin alpha by L. Just square and add, and we are done. 1 by SP minus 1 by L whole square plus 1 by SQ minus 1 by L whole square equals E square by L square. So you can clearly feel like these portions of distances. Imagine if I have SP and SQ, this represents a length, right? Suppose we have SP axis and SQ axis. It seems quite weird, but it's so interesting. So let's say these two lengths are represented by this. So if we plot this length, because there can be many chords which makes, like 90 degree on the focus. There can be so many, infinitely many chords which makes 90 degree with the focus. So if we'll plot this, so 1 by SP, let's say that's, if I plot 1 by SP rather, and 1 by SQ, it behaves like a circle, right? Circle with 1 by L comma 1 by L as the center and some EY as a radius. Okay, so maybe the JE can directly ask you the graph between 1 by SP and 1 by SQ as P and Q varies in such a way so that it always behaves 90 degrees at the center. So you see like how beautiful in one line you are able to solve this question. I'm sure you must have enjoyed this unit technique, and it will be very helpful especially for those problems where distances are involved. And in one shot you can kill parabola, hyperbola and ellipse. For circle, mainly we go with circle geometry. For more quality content, please do subscribe to the channel, because all what I am doing is just for the sake of love. For more quality content, please do subscribe my channel and try to share with your friends so that you can get more quality content for free.